This is how I carry my sluice around. Test their soil, find out if they got any gold in it, and I just wanted to show you how it travels compacted. Nice and neat. About 2.5 inches wide by 20 feet long is this. Okay, now that you've finished draining the excess water from your sand and silt that you've collected, leave it in the bucket and then put it out in the sun to dry, because at this point we want to completely dry it out. And what you're going to do is you're going to take a rake, a small shovel, whatever it takes to keep mixing up the sand in here until it's perfectly dry. You want it completely dry, other than whatever ambient moisture is in the air. That's okay. But the point is, get it dry, all the moisture out. You want this to be totally devoid of water. And it might take a few days to keep stirring it around, letting it dry out, making sure you get to the bottom, because the point is without stirring it up, it'll get packed and very compact, and it'll turn lumpy, and it'll be difficult to sift in this next process that I'm going to show you. In which case, now that we're at this dry point, you want to definitely wear protection. Gotta have a nice vest, right? And eye protection. How's that? And a little sun protection. What we need to do now at this point is one more refinement before the amalgamation process, in which case we need to extract all the ferrous metals and the magnetite from the sand, because we don't want that to amalgamate. And the way to get that out, to refine that, is with a magnet. Here I have a handheld bar magnet. This thing can pick up 100 pounds of metal. That's how strong this magnet is. What I've done is I've taped cardboard to the sides, to the edges, so that I have a trough through which the sand's going to go through. We're going to lay a nice thin piece of plastic. In this case, this is one piece of a Ziploc bag. Make sure that's secure by using a clip or something. And there you go. This is the last sifting process. You're going to run the sand through this trough, and it's going to pick up any ferrous metals, iron filings, whatever's in the dirt, but most importantly, the magnetite. So this is the basic process, the gist of it. We're going to use a funnel to drop your sand in to the trough, and you want to shake it. And just shake, shake, shake. Don't worry about not picking up or losing any of the magnetite or ferrous metals, because this 100-pound magnet, it picks up everything. You don't want the input to exceed the output. So basically, you only want enough sand to run through this trough so you're constantly seeing the bottom of it. You don't want this to be filled with sand, because otherwise you will lose magnetite and ferrous metals into the final process, which you don't want to do. And there you have it. So what we have here is, as you can see, the magnetite has been picked up by the magnet. It's sitting right there. It's not going anywhere. Collected all the magnetite from the previous siftings in the magnet process. And then what you want to basically do is, how simple is this? Take the clip off. You lift your plastic off of the magnet, and the magnetite just drops out. Simple, quick and easy. I'm going to take another magnet. Any magnet will do. And you want to put it into a plastic bag, like so. You don't need to close it up. Just pinch the sides, the back, so you have a flat surface. And then you want to pick up the magnetite that you just processed. You want to basically pick up that, because there's a lot of dust that gets caught in between the cracks of the magnetite, and that dust is super refined and extremely concentrated other stuff. So you want to take out all the magnetite from that, and since it's in a bag, once you're done, you just lift the magnet out of the bag and drop it onto your batch of magnetite. Now then, that's what we have here. We have, out of 80 pounds that I went through, 2 ounces right here. of magnetite. So that's the equivalent of approximately 40-to-1 ratio, which is important to know because this is only the test batch. I want to know the ratio in this because I have in silt, which I'm not going to do all this processing that I just showed you and went through to get to this point. That gets sent to an assayer to know approximately what you might be getting out of that process. You're going to want to know your ratio. That way you know if they've given you a bad deal or if they're true and you're true to yourself. So yeah, there you go. Next phase is the amalgamation process. I'll show you that next. So what do we have here? Big things come in small containers. And in this one we have high grade quicksilver, or aka mercury. This is 1/7 of a cup, and it weighs 1 pound. That means a cup of this stuff would weigh 7 pounds. Alright, this is super potent stuff, and actually, if you care to get closer to your monitor, I have something really important to tell you, and that is that this is very, very, very explosive! No, I'm just kidding. Just kidding. But on that note, it's just as dangerous to work with. So in that case, you need to know some precautionary measures. And that is, for instance, you want to have gloves. I use nitrile or neoprene. You want to have an extra airtight sealable container in case you need to stop your process and hold off for a little bit. Of course, a little this to be able to put it in there. And most importantly, you want to have a gas and face mask, because mercury does in fact evaporate. So the hotter the atmosphere is, the more is going to evaporate. So it's best to work with this under the coldest or coolest conditions possible, and always wear a mask that covers your face and all orifices, because you don't want to ingest this stuff, and you certainly don't want to breathe any of the vapor that could be locking off. So be prepared. You need to have everything set up beforehand before you do the processing. This is chamois. I'm going to show you what that is for later. Anyway, here we go.